Alright guys, today we are going to start by talking about systems of equations. Now, in the past chapters we've talked about how to solve equations with one variable. So for example, if I have like 2x plus 6 equals 12, we know that we can subtract 6 from each side, and we can divide each side by 2, and we'll get a value of x equals 3. So when there's an equation with one variable that we don't know, we can easily solve it and get down to the answer of x equals whatever. Now today, we're going to start talking about what happens when we have more than one variable. So for example, if I were to have like 2x plus 3y equals 5, how to solve that guy? Well, unfortunately, we can't solve that guy other than the fact that we could say like 3y equals negative 2x plus 5, and then y equals negative 2/3 x plus 5/3. That's as far as we can get. We can't get a numerical value for y or a numerical value for x because we have two things that we don't know, and we can't know one without the other. So when we have an equation with two variables, we're going to talk about how we can get numerical values in return. And to do that, what we're going to have to do is we're going to have more than one equation. And that's when we get what's called a system of equations. When we have more than one equation, it's called a system of equations. So on number 1 on your practice, it says solve the following systems by graphing them. So our two equations, y equals x plus 2 and y equals negative 3x plus 6. If we were to look at them individually without one another, we wouldn't be able to solve them because we only have one equation with two things that we don't know. But since we have two of them, we can solve both of them, and that will give us a result. So the first method that we're going to learn of how to solve systems of equations is by graphing. And so what we're going to have to do is, first of all, we need to check to make sure that both of our equations are in slope-intercept form. So just a quick reminder, slope-intercept form is y equals mx plus b, where m represents our slope and b represents our y-intercept. So my first equation, y equals x plus 2, slope is 1, y-intercept is 2. Second equation, y equals negative 3x plus 6, slope is negative 3, y-intercept is 6. So since they're both in slope-intercept form, what we're going to do is we're going to graph both of them onto the same coordinate grid. Okay, so I'm going to start with my first guy here, y equals x plus 2. So if my y-intercept is 2, that means I'm going to start with a point at 2 on my y-axis. Then I have a slope of 1. Now remember, a slope is technically 1, which is 1 over 1, and slope is rise over run. So we're going to go up 1 to the right 1, up 1 to the right 1. So if I start here, I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So when graphing normal graphs, you only need 4 points to call it a line. However, when solving systems of equations, we need to be a little more specific than that. So whenever you're graphing your first equation, you need to put as many points on the line as you can fit on your grid. So I'm going to keep going up 1 to the right 1, 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 up 1 to the right 1. Then I can still fit more points down here to the left. So I'm going to go the opposite direction, down 1 to the left 1, 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 and I'm going to go all the way until I can't go anymore. Once you've gone both directions, you can see you cannot fit any more points on that line on this graph. So now you're going to take your straight edge and you're going to connect it all the way through your grid, and you're going to end it with arrows. Okay? Now, on the exact same coordinate grid, you're going to graph the second line. So if I were to graph y equals negative 3x plus 6, the y-intercept is 6, so I'm going to come up here on the y-axis and start at 6, and my slope is negative 3. Now if it's a slope of negative 3, that's a negative 3 over positive 1, so that means I'm going to go down 3 to the right 1. So from this point, I'm going to go down 3 to the right 1. And notice I intersect with my red graph. Whoa, okay. I intersect with my red graph right on a point, and that's exactly what we want. If you do not land on a point on your original graph, you're doing something wrong. Then I'm going to go this on the second graph. That's when you only need 4 points. So down 3 to the right one, and again, down 3 to the right one, and again, down 3 to the right one. Once you have your 4 points and it hits your first graph on a point, you can connect it with a straight edge all the way through. Okay? Now, you should have 2 lines graphed on the same graph. And the point where they hit each other, the exact coordinate where they lie on top of each other, that is your answer. So my answer is going to be the ordered pair of 1, 3. Now, if you'll notice, when we had one equation, or an equation with one variable that we didn't know, we had one answer, x equals something, y equals something, blah, blah, blah. Since we have 2 variables that we do not know, that means we're going to have 2 numbers as our answers, which is why it's an ordered pair. Now here's what this ordered pair means. If we were to substitute this ordered pair, it would work for both of these equations. So for example, ordered pairs are written in the order of x comma y. So if I were to take this equation right here and substitute these numbers in, they would work. So if I substituted in 1 for x, I'd get y equals 1 plus 2. 1 plus 2 is 3, so y equals 3. So when x equals 1, y equals 3 in my first equation. And it will also work for my second equation. So y equals negative 3 times 1 plus 6. Well, negative 3 times 1 is negative 3, plus 6 is 3, so y equals 3. So in this equation as well, when x equals 1, y equals 3. Now that is the only ordered pair that will work for both of those lines. If I were to choose another ordered pair, say for example, let's go 3, 5. Let's see if it works for my first equation. So y equals 3 plus 2. Well, 3 plus 2 is 5, so y equals 5. So this definitely works for the first equation, okay? But if I were to substitute it into the second, y equals negative 3 times 3 plus 6. Negative 3 times 3 is negative 9. Negative 9 plus 6 is negative 3. So I don't get the 5 back. So it does not work for the second equation. So to figure out what ordered pair, what numbers are true for both equations, you can graph them and see where they cross. Now, it's important that you graph every single point. You plot every single point on that first line, so when you plot your second line, you can see where it intersects exactly at an ordered pair. Because what we don't want is we don't want for you guys to be going, and then when you cross the line it looks like it's somewhere in between, and you're not 100% sure if it lands on an intersection or not. When you have all the points plotted on your first line, you know yes or no if it hits the line on a point. So let's go to number 2. On number 2, I have 2 equations, both in slope-intercept form, so we're going to start by graphing my first guy. Y equals 3x plus 3. 3 is my y-intercept, so I'm going to start at 3 on the y-axis. And my slope is a positive 3, which remember is positive 3 over 1. So I'm going to go up 3 to the right 1, up 3 to the right 1, and I cannot go up anymore, so I'm going to go the opposite direction. Down 3 to the left 1, down 3 to the left 1, down 3 to the left 1, down 3 to the left 1. So once you've plotted all the points that you can fit on that first equation, you can connect it with a straight edge. Now remember, you want to connect all the way through and you want to end it with arrows. Now let's go to our second equation, y equals 2x minus 1. So my y-intercept is a negative 1, so I want to start at negative 1 on the y-axis. And my slope is a positive 2, so I want to go up 2 to the right 1. So if I start here and I go up 2 to the right 1, up 2 to the right 1, if you'll notice, I actually happen to be getting further away from my original purple line. That definitely doesn't help me find where they cross or they intersect. So instead of up 2 to the right 1, let's go the other way. Let's go down 2 to the left 1. Now at this point, I hope you guys notice that I have 4 points. So some of you might be excited to go ahead and draw your line and call it good. But remember, for the second line, you have to have at least 4 points and you have to hit the second graph. So I need to keep going until I find that ordered pair where they hit. So again, I go down 2 to the left one, still not good. Down 2 to the left one, still haven't hit it. It's close. Let's try again. Down 2 to the left one, and right there we land right on the line. So now that we've hit it and we have 4 points, we can connect it with a straight edge all the way through and end it with arrows. Now, let's find out what our answer is. Our answer is where the two lines, I don't know why that won't erase, where our two lines cross each other. What is happening? Okay, let's try again. Now our answer is going to be where our two lines cross each other. They cross each other right at this ordered pair, so this ordered pair is going to be our solution. So that ordered pair is -4, -9. Alright, so if we go to number 3. Number 3 we have y equals 2x plus 1 and y equals -3x plus 6. So here's what I'd like you to do. Pause the video and graph just the first equation on your own. Hopefully when you graphed it, you plotted every single point and you had a y-intercept of 1 and a slope of +2, so up 2 to the right 1. Now I'd like you to pause the video and graph the second equation, y equals -3x plus 6, all on your own. Be careful with the negative slope. Now when you plot your second one, it should start at 6 and go down 3 to the right 1. After 1 point, you should find the intersection, which is right here at 1, 3, and that is our answer, 1, 3. On number 4, the first equation that we have is y equals x. Now a lot of people get a little nervous when they see this, but remember, it still has two variables. So that means it is an oblique line. So y equals x is still in the form of y equals mx plus b. M represents my slope, b represents my y-intercept. So the number in front of the x is my slope. Well, the number in front of the x here is a 1, so my slope is 1, and the number being added to the end is where we start. Well, there's nothing being added on to the end here, so that means my y-intercept is 0. So to plot this, we're actually going to start at 0, 0 at the origin. And my slope is a +1, so I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And we're going to keep going all the way to the end. Then we're going to turn around and we're going to go the other way, down 1 to the left 1, all the way till the end. Once you have plotted all of your points, you're going to connect it all the way through with a straight edge. Then you're going to end it with arrows. So that's going to be the graph of y equals x. And this should be the easiest graph for you guys to graph, but for some reason we really struggle with it. Now my second equation, 2x plus 3y equals -15, I can't graph that because that's not in slope-intercept form. So we're going to have to solve for y before I can graph it. So to solve for y, I'm going to start by subtracting 2x. And when I do that, on the left side, the 2x's will cancel out, and that's going to leave me with 3y. And on the right side, -15 and -2x are not like terms, so they stay separate. The x term goes first, so -2x minus 15. Next, to solve for y, I need to divide each term by 3. So the 3's cancel out and leave me with y equals -2x divided by 3. Remember, the slope goes first, so -2 divided by 3 is -2/3. Bring down your x, and -15 divided by 3 is -5. Now that we have this in slope-intercept form, it's much easier to graph. I have a y-intercept of -5, so that's going to be down here. And then I have a slope of -2/3. So I'm going to go, remember it's rise over run, so down 2 to the right 3. So from here we're going to go down 2 to the right 3, down 2 to the right 3, but this really isn't helping us because we're going away from my blue graph. I want to go the opposite direction. So instead, let's start at the origin, or the y-intercept, and we'll go up 2 to the left 3. And right there, we intersect our original graph. So I have 4 points and it crosses, so I can go ahead and I can connect with a straight edge. Alright. Now where they cross, this guy right here, that's our answer. So my answer as an ordered pair is -3, -3. Okay, we are going to skip number 5 and go down to number 6. On number 6, I have y equals -3x plus 8. Well, we can definitely graph that. So here's what I'd like you to do. I'd like you to pause the video and graph the first equation on number 6 completely on your own. Okay, your graph should look like my graph on the screen. We'll have -3x plus 8 with a y-intercept of 8 and a slope of -3. Now, before I can solve this, or graph the second one, I have to solve it. So let's solve for y, and we're going to subtract 6x from each side. That's going to leave me with 2y equals, these are not like terms, so the x term goes first, -6x plus 2. Then we can divide each term by 2, and I get y equals -3x plus 1. Now let's graph this guy now that we have it in slope-intercept form. So to graph it, I have a y-intercept of 1, so I'm going to start at 1 on the y-axis, and a slope of -3. So down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. I'm not getting any closer if I keep going this direction, so let's try the other direction. So I can go up 3 to the left 1, up 3 to the left 1, up 3 to the left 1. Well, that's weird. When I go that direction, I'm not getting any closer either. So let's go ahead and connect that with a straight edge and see what happens. Now, when I connect it with a straight edge, hopefully you can see that these two graphs are not getting any closer or any further apart at all. In fact, they're running right next to each other, and that's, remember, what we call parallel lines. Now, to know for without a doubt, to know 100% that these are parallel lines, you can always check their slopes. So my original line had a slope of -3, and my new line also has a slope of -3. So since they have the same slope, we know that no matter how far out we draw them, they will never ever cross. They will never intersect. So since they're never going to cross, since they never land on top of each other, that means we have no solutions. So spell it out, no solutions. These two lines will never ever meet, and so that means there is no ordered pair that's going to work for both of those equations. On number 7, let's go ahead and start by graphing the first equation. So I have y equals -x minus 3. So I have a y-intercept of -3. So here's my pin on the origin. I'm going to start at -3 on the y-axis. And I have a slope of -1. Remember, -1 is a -1 over a +1. So that's going to go down 1 to the right 1, down 1 to the right 1, and I'm just going to keep going, down 1 to the right 1. Now, once I run out of space, I got to go the opposite direction, up 1 to the left 1. And you keep going until you have no more room to go. Then you can connect it with a straight edge all the way through. Now with my second equation, y equals x minus 1, let's see what I get. I have a y-intercept of -1, so I'm going to start at -1 on the y-axis, and a slope of +1. So if I go up 1 to the right 1, up 1 to the right 1, I'm going the wrong direction. So let's try going the other direction. Down 1 to the left 1, and takes us right there, and right away we intersect one of the points from the other line. So I have 4 points, and I cross the other line, so I can go ahead and draw my line. And my solution is this ordered pair right here, which is -1, oops, -1, maybe, -1, comma, -2. All right, on number 8, I have y equals -x minus 3, and 2x plus 2y equals -6. So here's what I'd like you to do. I'd like you to pause the video and just graph the first equation. Then come back and we'll do the second one together. Now when you graph your first one, it should have a y-intercept of -3 and a slope of -1. Now to graph the second one, we first have to solve it for y. So I'm going to subtract 2x from each side. And I'm going to be left with 2y equals -2x minus 6. Divide each term by 2. That's a 2. And I'm going to be left with y equals -x minus 3. Now to graph this guy, we're going to start at -3. So here's my y-axis. I'm going to start at -3. And oh, right away we already hit our intersection. That's awesome. We just need 3 more points and we can call it a line. Now my slope is -1. So that means I'm going to go down 1 to the right 1. Down 1 to the right 1, down 1 to the right 1. Well, that's crazy. Each point that I plot is already on top of a point that I already have. If we look at why that is, let's compare our original equation to our new equation, our second one. If you'll notice, there is the exact same equations. And when that happens, when every single point is going to work, that means every single number is going to work in both of those equations, which means I'm going to have infinite solutions. Now don't forget to spell it out. We don't use any symbols. It's I-N-F-I-N-I-T-E, infinite solutions. All right, next we're going to skip number 9 and we're going to go down to number 10. I would like you to pause the video and do number 10 completely on your own. You're going to have to solve both equations and graph them. All right, so to graph these, first you have to solve the first equation, which I did down here. And when I solved 2x plus 2y equals -6, I got y equals -x minus 3. And that gives us the purple equation right here, the purple line on my graph. Then to solve my second equation, I subtracted 3x and I got y equals -3x plus 3, which is my blue equation up here. And they overlap, they cross each other right here at this nice ordered pair, and so my answer is 3, -6.